graph shows the speed of a car during the first 30 seconds of its journey. Speed, time, show the acceleration of the car after 20 seconds. So 20 seconds is 8, 20 seconds is here. What is the acceleration? Well, how much faster it's getting? Well, it's not. It's staying at 18 meters per second the whole way through on this part of the journey. So acceleration is 0. Because acceleration on a speed time graph is the gradient, and the gradient is 0 there. Find the total distance. The total distance is the area. So that's the area under the graph. That's what I need. And I'm going to do that. The first part is A, and that's B. So it's going to be area of A plus the area of B. A is a triangle, so it's going to be half times by the base, which is 8, times by the height, which is 18, plus the area of the rectangle, which is the base, and the base goes from 8 to 30, so that's 22 is the base. Got to be careful, it's not 30. It's from 8 to 30, which is 22, times by the height, which is 18, and that is 72 plus 396, and that is 468 meters. So the speed of the train is 68 kilometers per hour. Correct the nearest kilometre per hour. Write down inequality to show the error interval for V. So 68 is to the nearest kilometre, so it could be 68.5. Well, actually it couldn't be 68.5 because that would round up to 67. So the velocity has got to be less than 68.5. It could not equal 68.5. And beneath that, it could be 67.5. And it actually could equal 67.5. So it'll say that 67.5 is less than or equal to V. So if V were to be 67.5 to the nearest kilometre, it would round up to this. And it's got to be strictly less than 68.5. Because if it were to equal 68.5, then it would actually round up to 69. So that's the answer of that bit. And now we show the distance travelled by a lorry in 12 seconds. So what distance? Okay, so here we had speed time graph. This one got distance time graph. We've got to make sure we read the scales properly. Estimate the speed. Well, the speed is the gradient. So I need to find the gradient of the line after 5 seconds. So I need to find the gradient at that point there. And so I need to draw a tangent to that line and then see what the equation of that, so not equation, see what the gradient of that tangent is. So it's going to be something like, something along the lines of there. And now I have to try and work out what the gradient of that is. And all I have to do is just try to draw a right angle triangle. Well, I can see from my picture it goes through 2, so I'm going to use that. So does it go through anywhere else, which is nice? No. So I'm going to do this bit here, that bit there. So gradient, it is change in y divided by change in x, which is how much up's it gone. Well, according to mine, it's gone up, that would be 18. So it's gone up 18, and well, actually 18, it's gone up 18 meters. And how far across has it gone? It's gone across 4 seconds. So I do 18 divided by 4, which is 4.5, and that leaves me with meters divided by seconds, which gives meters per second. So actually you can sometimes use the units to help you, but this was a matter of drawing a tangent and then working out the gradient of that tangent. And that's 13 done.